Hello student, good morning. Today now I am going to discuss Charles' law. Last class I have discussed Boyle's law. Now I am continuing Charles' law. That is the temperature volume relationship. Charles' law is temperature volume relationship. Charles and Gallujax performed several experiments on gases independently to improve upon hot air balloon technology. Their investigation showed that for a fixed mass of a gas at constant pressure. Now here two things are constant. Mass is fixed and pressure is constant. Two things are constant, mass and pressure. Volume of a gas increases on increasing temperature. This is the Charles law. Volume of a gas increases on increasing temperature and decreases on cooling. Means when temperature decreases, volume decreases. When temperature increases, volume increases. This was the, you can say, conclusion of its research work. But the condition was that mass of the gas should be fixed and pressure also should be fixed, both. Okay. Then for a fixed mass of a gas at constant pressure, volume of a gas increases on increasing temperature and decreases on cooling. They found that for each degree rise in temperature, volume of a gas increases. I am going to tell very important things. Keep in your mind that for each degree rise in temperature, how much volume increases? This is important things. According to his research work, Charles has research work, what he found, for each degree rise in temperature, volume of a gas increases by 1 upon 273.15 of the original volume of the gas at 0 degree centigrade. Means when original gas was at 0 degree centigrade and 1 degree temperature was increased, then how much was the change in volume? How much volume increased? Then it was 1 divided by 273.15 of original volume at 0 degree. What was the volume of 0 degree? In that some increase taken place. Means what was the volume? There 1 upon 273.15. This is the important 1 upon 273.15 of original volume at 0 degree centigrade. Then each degree rise in temperature, volume increases 1 upon 273.15. This is very, very important. Then only on this basis he just proceeded and calculation can be done. Thus, if volume of the gas at 0 degree centigrade and a small t degree centigrade are V0 and Vt respectively. Okay, if you will consider that if volume of the gas at 0 degree Celsius and a small t degree centigrade are V0 and Vt. V0 and Vt means T is small. Then at Vt means when temperature you have increased, that time volume automatically will increase. That is the Vt. Then how much volume will be there? New volume. Then that is equal to new old volume means V0, original volume V0 plus increased volume. Then increased volume was how much? Then V0 divided by 273.15, because this increase per degree rise of temperature 1 divided by 273.15 increases of original volume. That's why for 1 degree this is the rise in volume due to 1 degree. Then due to the T degree, how much? You have to multiply by T. It means total increase in volume is V0 divided by 273.15 into T. This is the increased volume. Then now total volume, both you add, means V0 original volume plus this increased volume. Then you can write simply that V0 plus T into V0 divided by 273.15. This is the total volume Vt. Then after that, simple you can say this is there. Simple calculation is there, simplification, that V0 is common in both. In both term V0 is there. Original is V0 plus T into V0 divided by 273.15. Then V0 you take common, then inside what will remain in bracket? Then 1 plus T upon 273.15. This will remain. Okay. Then this Vt, this is now become Vt is equal to V0 in bracket, outside V0 in bracket 1 plus T divided by 273.15. Then again, if you will simplify this term, 1 plus T divided by 273.15, then you will get 273.15 plus T divided by 273.15. Simple calculation. Simple calculation. You will get 1 plus T upon 273.15. Then you take LCM and do simplification. Then you will get now Vt is equal to V0, and in bracket you will get 273.15 plus T divided by 273.15. Then now here two terms are there. First new term 273.15 plus T. This actually tells about the new scale of temperature, 273.15 plus T. This is telling about new scale of temperature such that T degrees Celsius on a new scale is given. That new scale, this will create a new scale or created new scale. Then what is the new scale? Means 273.15 plus T, small t, new scale of temperature, such that T degree centigrade on a new scale is given by capital T. Capital T is equal to 273.15 plus T, and 0 degree will be given by Down we have written at 273.15, that is called 0 degree Celsius. 273.15 plus T divided by 273.15. Then down 273.15 is called 0 degree. And above and upside 273.15 plus T, that is called a new scale, that is a capital T. Capital T, that is equal to 273.15 plus a small t. This new temperature scale means 273.15 plus T, that is called Kelvin temperature scale. Kelvin temperature scale or absolute temperature scale. This is very, very important things I have told you. And simply 273.15, that is called 0 degree Celsius. Thus 0 degree Celsius on the 0 degree centigrade on the Celsius scale is equal to 273.15 Kelvin. 273.15 plus T. If T is 0, then you will get 273.15 K, capital K, at the absolute scale. Means if you are knowing the value of in degree centigrade, I want to know in Kelvin, then you add it in 273.15. Then you will get value in Kelvin. Only K is written, not degree centigrade, only K. Okay. Thus 0 degree on the Celsius scale is equal to 273.15 K at absolute scale. Keep in mind, absolute scale is 273.15 plus T. If T value you are knowing, add it. Then you will get answer in Kelvin. Here you should note that the degree sign is not used while writing the temperature in absolute temperature scale. That is a Kelvin scale. Kelvin scale of temperature is also called thermodynamic scale. Objective type question they will ask. What is thermodynamic scale? Then Kelvin scale is also known as thermodynamic scale of temperature and is used in all scientific works. Thus, we add 273.15, we can tell only 273 also. Thus, we add 273 more just for simplicity to the Celsius temperature to obtain temperature at Kelvin scale. Now, I am going ahead just in a mathematical way how you will tell Charles' law. Okay. Then now if we write T small t, okay, that is equal to 273 plus T. If we write absolute temperature T, capital T, and down you can write a small t, no problem, you can write. Then capital T is equal to now 273.15 plus T, and T0, not TC, T0, that is equal to 273.15 or simply 273 you can tell. Okay. Then now we are considering two temperature. One is capital T and a small t down. That is equal to, because a small t you are adding because you are considering plus T, 273 plus T. That's why you are adding with capital T a small t down. And T0 means you are not adding. You are adding only 273.15. Then now what is the, you can say, these things. Now you have already, you have written Vt is equal to V0. Vt means total volume is equal to V0, or inside the bracket 273 plus T divided by 273, or exactly 273.15 plus T divided by 273.15. Then in the place of 273.15 plus T, you write T, capital T, absolute temperature, and down 273.15, for this you write T0. Then T, capital T, Tt, down T divided by T0. You can write Vt is equal to V0. Now Tt divided by T0. Okay. T, capital T, down small t divided by T0. This you can write. After that you can do the rearrangement. Means Vt upon V0 is equal to Tt upon T0. This is these things, Charles law. But now you can simplify further. Vt upon V0, that is equal to Tt upon T0. Then now in the term of V1, V2 also you can write, and T1 and T2, like that you can write. That's, we can write a general equation as, in the place of Vt you can write V2, and in the place of V0 you can write V1. You are not doing only term 1 and 2 you are introducing. For the more you write 2, for the less you write 1. Means for the 0 you write 1, and for the Vt you write 2. For the 0 you write 1, and for the T you write 2. Then it will become V2 upon V1. That is equal to, again same things, for it becomes T2 upon T1. For the 0 you have written 1, and for that small t you have written 2. Then it becomes T2 upon T1. Hence finally you are getting V2 upon V1 divided by T2 upon T1. Okay. Then now easily these things again you can rearrange V1 upon T1. Only from this equation, simply rearrange V1 upon T1 is equal to V2 upon T2. Okay. Next step, you can arrange, because it is the V2 upon V1, that is equal to T2 upon T1. Then you can also write V1 upon T1 is equal to V2 upon T2. And finally you can write V upon T is equal to constant, that is equal to K. Correct? Then B upon T, this value experimentally we just found that it is a constant. V1 upon T1, this value is equal to V2 upon T2, that is equal to constant. Hence, even you will write V3 by T3, V4 by T4, V5 by T5, then all value will be equal. That is the constant. That's why in a simple way, why will you write so many? You write only one. Then V upon T, that value is equal to constant. That is equal to K, you can write. Then V upon T, that is a constant. Okay? That is equal to K. Means V upon T is equal to K. Then V is equal to K into T. You can write V is equal to K into T. Then now it is the equality sign. V is equal to K into T. If you want to write in a proportionality form, then you have to remove K. Then it will come V is directly proportional to T. If you will remove K, equality sign you want to convert into the proportionality. Then you remove the K. Then it will become B is directly proportional to T, and the value of constant K is determined by the pressure of the gas. K value, constant value, is determined by the pressure of the gas. Its amount, what amount you have kept constant, what pressure was you have considered during experiment or was considered, what was the pressure, what was the amount of gas, on that this K value, always K value will depend upon the constant terms in a simple way. Then here constant term was pressure and mass of the gas. Then K value will depend upon that. In Boyle's law also same thing happened. That K value depended on the, you can say, constant terms. Now this B is directly proportional, B is directly proportional to T, that is known as Charles' law. Okay. Then Charles' law, which states that pressure remaining constant, the volume of a fixed amount of gas is directly proportional to the absolute temperature. Again I am telling you, Charles' law states that pressure remaining constant, the volume of a fixed mass of a gas is directly proportional to its absolute temperature. This is a very, very important law I have told you. Again I am continuing. Charles found that for all gases at any given pressure, graph of volume versus temperature, in Boyle's law it was pressure versus volume. Here volume versus temperature, because pressure is fixed, constant. Then here, according to Charles' law found that for all gases at any given pressure, graph of volume versus temperature is a straight line, and on extending to zero volume, it is a straight line, and on extending to zero volume, each line intercepts the temperature axis at minus 273.15, you can say degrees Celsius, 273.15 degrees Celsius. This is important, minus 273. If you will, all straight lines, if you will extend it towards zero, towards origin, then what you will find, all straight lines are meeting in one place, and that time what is the temperature? Then temperature is minus 273.15. Then see, all when pressure is constant and volume versus temperatures, this plot you are drawing at different pressure, suppose P1 pressure, P2 pressure, P3 pressure, P4 pressure, and if you will extend it, this straight line, then slowly all will meet to one place, and that time temperature will be minus 273.15. Slopes of lines obtained at different pressure are different, but at zero volume, all the lines meet the temperature axis at minus 273.15. That time, at this temperature, volume becomes zero. Keep in mind. You know that if temperature will be, if you will decrease the temperature, volume decreases, you know. If you will decrease the temperature, volume decreases. Then a temperature comes, at what temperature volume will be 0 of 1 mole of gas? Then that temperature is minus 273.15. Actually, this lowest temperature you can tell, that is imaginary only. Till date, no gas has found 0 volume. Okay, up to these things, minus in the case of helium, minus 134 has been found out, not minus 273. Then at this temperature, volume becomes 0 of 1 mole of gas. This is theoretical, imaginary. But this temperature, minus 273.15, what is this temperature? Then this temperature is called absolute 0. Keep in mind, question is asked. Absolute 0. I already told you, each line of the volume versus temperature graph is called isobar. This is a new term for you. Each line means when pressure is constant. When pressure is constant and you have drawn the graph volume versus temperature, and pressure is constant, then each line of the volume versus temperature graph is called isobar. In the case of Boyle's law, when temperature was constant, then each line was called what? Isotherm. Now here it is called isobar. Obviously, or also I can tell, observation of Charles can be interpreted if we put the value of, you can say, temperature, what I have told in that equation. And simply you understand like that this minus 273.15 temperature, that is the lowest hypothetical imaginary temperature at which gases are supposed to occupy 0 volume, and this temperature is called absolute 0. Absolute 0. All gases obey Charles' law at very low pressure and high temperature. This you understand, question is asked. All gases obey Charles' law at very low pressure. Why low pressure? Low pressure and high temperature. Then at low pressure what will happen? Volume will be more. When pressure is low, then gas will expand. Gas will expand, volume will be more. There will get chance to expand. That's why at very low pressure and high temperature. Then high temperature means again same things. You know that if you will increase the temperature, then gas expands. You want actually expansion. Then for the expansion, condition is that temperature should be more than gas will expand. And also if pressure is low, then again that time also gas will expand, because high pressure volume will be less. Then in less pressure volume will be more. Then you want more, you can say volume, more volume, expansion you want. Then for expansion these two conditions are there. Volume, this temperature should be high and pressure should be less, very less. Only in that condition, only at these two conditions, all gases obeys Charles' law. All gases obey Charles' law at a very low pressure and high temperature. I have discussed about the Charles' law. Now I am going to discuss Gallujax law. Gallujax law. What is the Gallujax law? That is the pressure temperature relationship, PT. P and T relation, pressure temperature relationship. Okay, that this is because numericals is also asked on this concept. Okay, I will tell one numericals based on Charles law and the end. Okay, this you should understand now Gallujax law, that is a pressure temperature relationship. Pressure is in well inflated types of automobiles is almost constant in tires. In bike, we are talking about the tires. Pressure in well inflated tires of automobiles is almost constant. But on a hot summer day, this increases considerably and tire may burst if pressure is not adjusted properly. During winter, reverse case. During winter, on a cold morning, one may find the pressure in the tire of the vehicles decreased considerably. The mathematical relationship between the pressure and temperature was given by Joseph Gallujax and is known as Gallujax law. It states that at constant volume, now you can see one by one, Boyle's law, temperature was constant. Charles' law, pressure was constant. Now here volume is constant. And given amount of gas, that is already constant in all cases. Then here what is the these things? Gallujax law. Then Gallujax law states that at constant volume, pressure of a fixed amount of gas varies directly with the temperature. Mathematically, P is directly proportional to capital T. P means pressure is directly proportional to T. Then again, if you want to convert into the equality, then you have to multiply by some constant. Then that time it will become P is equal to KT. K is constant. K is a constant. Then P by T is equal to constant. P is equal to KT. P is equal to KT. Then P upon T is equal to K, that is equal to constant. Then this is the Gallujax law, P upon T is equal to constant. This relationship can be derived from the Boyle's law and Charles' law. This relationship also can be derived from the Boyle's law and Charles' law. Pressure versus temperature graph at constant molar, we will send it. Okay, no problem. Pressure versus temperature graph at constant molar volume, we will send you. And this again one law is there. Each line of this graph, I will send you graph of this also. Okay, that is the pressure versus temperature Kelvin graph at constant molar volume. Already I have told you here each line of the graph, in this case when V is constant, that is called isochore. When volume is constant, then that straight line graph, it means in the case of Gallujax law, this straight line graph, that is called isochore. When volume is constant, that time a straight line graph means pressure versus temperature is called isochore. Pressure versus temperature. Okay, then now just this I have finished Gallujax also, and one numerical based on Charles' law, easy numericals is there. You can understand that here you know that four things are required. Already I told you V1 T1 is equal to V2 upon T2. This is the Charles' law. Then here four things are there. V1 T1 is equal to V2. V1 T1, V1 divided by T1 equal to V2 by T2. 4 terms are there. Then out of 4 terms, 3 terms is given. Means 2 volume is required and 2 temperature is required. Then here very easy numericals is asking in examination that they will give out of 4, 3 they will give, and 4th one you have to derive. Very simple things. Then here question is that, question I am reading, on a ship sailing in a Pacific Ocean where temperature is 23.4 degrees centigrade. Okay. In Pacific Ocean, temperature is 23.4 degrees centigrade. One temperature is given. A balloon is filled with 2 liter air. Then now one volume is given, 2 liter. Okay. When temperature is now given and one volume is given. Now, what will be the volume? Now the second volume they are asking. What will be the volume of the balloon when the ship reaches Indian Ocean where temperature is 26.1 degrees centigrade? Means second temperature is given. 2 temperature is given, 1 volume is given. Then second temperature they are asking. Means first volume was 2 liter and second volume you have to find out, and first temperature was 23.4, T1 was 23.4 and T2 is 26. Means more temperature will be the T2. Okay, then T2 was 26.1. Then in temperature you add 273. It will convert into the Kelvin. 26.1 plus 273, 299.1 Kelvin. Temperature you have converted in Kelvin, volume will be in liter only. Then both temperature 23.4 plus 273 Kelvin, that become 296. Then T1, T2 you are knowing, and V1 you are knowing. V2 you can calculate. V1 upon T1 is equal to V2 upon T2. Then put all the value and V2 you can calculate. V2 is equal to V1 up into T1 divided, V2 is equal to V1 into T2 divided by T1. Correct? From the formula, easily you can know V2 is equal to V1 into T1 divided by V2 is equal to V1 into T2 divided by T1. Okay, by cross multiplication you will get this formula. Then now put the value. V1 is equal to 2 liter, T2 is equal to 299.1 Kelvin and T1 is equal to 296.4 Kelvin. Kelvin will be cancelled and 299 divided by 296 is there, and upside 2 liter. 2L into 299 divided by 296. Then you will finally get 2.018 liter. Means final volume will be V2 is equal to 2.018 liter. That is very easy numericals. Okay, all numericals will be like that. Only you have to understand the question. Question they will give a typical question and they will try to make it complicated. But now you search what they have given and then you apply the formula. This applies for all, for Boyle's law, Charles' law, Gallujax law, everywhere same concept. You should understand the question and what they have given and which formula will be used. That's enough. Today I am stopping only here. Next class again we will meet. Thank you.